Just I have opened one PowerPoint. Is it visible? Hello?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir. Visible.
Okay.
Yes, sir.
Okay, very good. So this is the actually chapter 1 in our first chapter that is related with the organic reaction mechanism and some important reagents. Some important reagents. And before going in details about this chapter, just I will say you in such a way that you have learned organic chemistry in class 11, 12, and you have also solved so many hard problems for JEE main and advanced. And there you have learned so many name reactions, but uh, as per your syllabus in 11, 12, that was only the reactions, their application you have learned, but their mechanism that was not included. But so many students for their own interest, they have learned, but it is not, as it is not included. So we have tried to explain some mechanism of reactions, so mechanism of reaction. So anyone can say just what do you mean by mechanism? Anyone? Hello? Can you explain what do you mean by mechanism? Organic reaction mechanism? What subject it's deal? Anyone?
So transfer of electrons, hydrogen.
Transfer of electron and hydrogen. Any more about anyone from? But it's quite related. Okay, relevant, but it is not clearly. You have not said.
What flow of reaction? How the reaction is going on? That thing.
How the reaction is going on? That is it. That regulated by the condition. Okay. Okay, so it is not clear. I think it is not clear. I will say you the definition and all these things related with the mechanism. Okay, so these chapters that deals with the organic reaction mechanism, no doubt I will explain about the mechanism, what I ask you. And in this syllabus, you see this is the chapter 1, that is the fundamentals of organic reaction mechanism, few important reactions and their mechanism along with their applications. And which reactions we will study? Robinson annulation reaction, hydroboration reaction, metathesis reaction, Wittig reaction, organometallic reagent, and Gilmer reagent. And this chapter that actually offline that actually we deals the chapter with 3 lectures, but online we will complete within 2 lectures. Okay, so rapidly we have to say all these things. Now you should ask me, sir, we have learned so many reactions, actually carbon, hydrogen, nitrogen, oxygen, sulfur, only these compounds, millions compounds till now actually synthesized and characterized, and their applications that we enjoy. So millions into 5, if you consider one compound is related to other 5 reactions, then you consider how many reactions it will be. So all these reaction is not possible to understand or to study within a lifetime of a professor or any within a lifetime of a person, people. So we have categorized all the reactions, particularly 5 category, that is the addition reaction, elimination reaction, substitution reaction, condensation reaction, and rearrangement reactions. And also someone say it is the pericyclic reaction, so that is actually almost thus within the group of reactions. So this category actually we have categorized the reaction actually to frame the actually the reactions as well as their mechanism, At the same time, I will say you at least 2 to 300 name reactions are there in organic chemistry, as per they are actually discoverer. Actually, name reactions are there. So among 2 or 300 name reactions, only 3 reactions we have included here. What is actually number one? Actually Robinson annulation reaction. Hydroboration reaction, it is not exactly the name reaction, but I will say you the details about this hydroboration reaction. And Graves catalyst, actually metathesis reaction. Actually, it is known related with the catalyst. Name is actually catalyst is more important. Wettig reaction and also Gilman reagent. Actually discovered Sir Gilman. Okay, so these reactions one by one I will try to highlight. And why these reactions only included? Because these or reactions are the milestone in the development of chemistry as well as inorganic chemistry. So these reactions that play important role in our daily life as well as actually day to day research are going on based on these reactions. And for these reactions, for fundamental reactions, they were most of these scientists are awarded Nobel. Awarded Nobel. So this is about the syllabus. And now I will say you about the mechanism. Actually, mechanism, that is the subject of organic chemistry or inorganic chemistry. Actually, the when any reactions proceed to reactant to product, it might go through the single step or might be double step, a two step, three step or multi steps. So reaction might be proceed single step or multi step process. So there each and every steps have some elementary change. Elementary change means either bond making or bond breaking. So all the bond making and bond making within the tenure of the reactions, they are involved intermediate or transition state. If we can represent that reactions as a whole, then that is known as reaction mechanism. Means actually where the bond is breaking, where the bond is making, and whether it the reactions when it is the multi-step reactions, whether it is going to through transition state or intermediate. So these all these actually parameters that actually that related with the mechanism. So when these are actually presented in the reaction, that is known as mechanism. And if you read any book, particularly for this chapter, I will say you to follow the Graham Solomon, Organic Chemistry, Graham Solomon, and also I.L. Finner. But all the materials you will not get from a single book for a single book. Okay, so you have to read several books in your home. Might not available the all the organic books, chemistry books, but when you will come in our campus, then all the books are available in our library. You can issue from there. Okay, so all these reactions, if you follow any reactions, they are written. The reaction is uncertain, the reaction is certain, and most probable mechanism. What is the meaning of these three terms? Number one, first of all, I will say you about the reaction is certain. Reaction is certain means if all the steps and their transition state or intermediates are characterized or properly known and presented in the reactions, then the reaction is known as and is written as a the reaction is certain. Reaction is certain. And the reaction is uncertain means when the reaction passes to through three or four steps or two steps. One is identified the transition state or intermediate or some exchange of reactions, but that intermediate or transition state is not actually characterized, then the reaction is known as most probable mechanism. And the reaction is uncertain. The reaction is uncertain and most probable mechanism if the reaction mechanism is not at all establish the different or establish the all the steps, particularly that involved transition state or intermediate, then the reaction is known as most probable mechanism. Most probable mechanism. So all these things actually related with the mechanism. And again, the about the fundamentals of organic reaction mechanism, I think all you have learned in 11, 12. That is inductive effect, electromeric effect, hyperconjugation, resonance, steric effect, mesomeric effect. So these are the tools. We say these are the tools to explain the mechanism. To explain the mechanism. Actually, I think all you know technician, they have some toolbox, and for actually doing any mechanical or some repairing of some actually motor or machine, they use the toolbox for different purpose as per their suitability. So in our organic chemistry, this what I told you: inductive effect, electromeric effect, hyperconjugation, resonance, mesomeric effect, steric effect. These are the tools. You have to learn all these things, and already you have learned in 11, 12. So not necessary to explain all these things. So if you can understand all these actually fundamentals terms, then it is easier to follow the organic reaction mechanism. Okay, now you can ask me, sir, you are starting this chapter with the syllabus as well as some photo of some chemist. Chemist, why? Actually, yes, the question is very relevant because all these scientists, they have contribute to the science as well as in chemistry for their fundamental works, and for their fundamentals work they were awarded Nobel. They were awarded Nobel, and they posted their milestone in the development of organic chemistry. So accordingly, we have presented. I have presented the photograph of Robinson, Robert Robinson. Then Venkataraman Ramakrishnan, actually he is Indian, but he is done mostly in ribosome, that is the biology, in the field of biology. But he was actually now citizen of USA, but Indian origin. And Grignard, he was also the Nobel laureate, as well as actually H.C. Brown, George Wittig, then these three scientists, that is the H. Graves, Richard Socks, and Vas Chauvin. So why these photos are presented here? Because these personalities have contributed to the development of chemistry, and we will try to explain their reaction, why these are important. So first of all, we will discuss on hydroboration reaction. Hydroboration reaction was discovered by H.C. Brown, but this reaction is not, as per his name, have a interesting history. If you like, then I will say you at the end of this class. So about the hydroboration reaction, already you have learned in 11, 12, and you have solved so many problems, but we will highlight here actually to get the flavor of mechanism, as well as I will say you about the what I say about the different steps of mechanism, and his contribution in the development organic chemistry. Now about the reaction, this is very simple. Alkene, this is the unsymmetrical alkene, that is 2-methyl propene. So 2-methyl propene, when treated with BH3 in tetrahydrofuran, actually tetrahydrofuran that act as a solvent, as well as to actually help to remain as a monomer of BH3. And BH3, that is the hydride donor. I think all you know that one hydride that can be transferred from BH3, and this BH hydride that will transfer to the carbon which contains the least number of hydrogen, as per anti-Markovnikov rule. So that will actually hydride that attach to this carbon-carbon double bond, actually due to electromeric effect. CH2 part the pi electrons that shift towards this CH2, and it will be the positive, and the CH2 that will be negative. But this is the actually, as per our terms, electromeric effect. But addition of hydride as well as addition of BH2 to the double bond, that is actually in seen away, and simultaneously it occur. Actually at a time, bond making and bond making, that is actually involved, and it gives the addition product, that is the hydride to the carbon, which contains the least number of hydrogen, means which attached to the 2-methyl group, and BH2 that attached to CH2. So this is the hello. Okay, so this is the addition. Now you have to actually hydrolyze this one. Actually, if you hydrolyze in the first step, so hydrolysis that can be done in presence of hydrogen peroxide and sodium hydroxide, and sodium hydroxide that actually base that abstract one proton from hydrogen peroxide, and it forms a peroxy anion. And that peroxy anion that actually attack to the boron, I will show you next step the mechanism, how it will actually hydrolyze, and ultimately after hydrolyze we get the alcohol attached to the OH group, which is sterically less hindered position. Okay, so this is actually not a new, but what you have learned in 11-12 that I have recapitulated. Now you see here, this is the 1-hexene. This is the 1-hexene. 1-hexene when treated with boron and diethyl ether in diglyme. Actually, diglyme is also helps to stabilize this BH3 and diethyl ether that act as solvent, and a step-by-step process actually 3-alkyl group that attach to boron, and it become trialkyl boron. It become a trialkyl boron, and trialkyl boron in presence of hydrogen peroxide and sodium hydroxide in aqueous solution, that gives corresponding alcohol. So here no mechanism has been presented, only the reaction scheme has been shown, and this is the HC Brown, his photo. And next, this is the mechanism. You see here the actually most important thing is the addition of the peroxide to the boron. Actually, I think all you know the electronegativity, the electronic configuration of boron, and 5 electrons are there. That is 1s, 1s2, 2s2, 2p1. So in a principal quantum number n equals to 1, so it is by quite a small orbital size. So when it is actually donated from the actually peroxy anion to the vacant orbital of the p, then it actually feels steric repulsion. So what happened, actually the boron become the negatively charged. So due to relieve its strain within the molecule, actually 1-alkyl group that actually shifted to the neighboring oxygen, simultaneously expulsion of OH, means the OH minus, that is the base. So this is the base catalyzed reaction, and it forms alkoxy dialkyl boron, alkoxy dialkyl boron. So this is the first step. In the second step, again the same reaction is repeated at the peroxide that actually attack at this boron in the same manner, and at the same time 1-alkyl group that actually transferred to this oxygen, and simultaneous expulsion of OH, and it from dialkoxy. In the similar way, this is the trialkoxy boron. So when trialkyl boron in presence of water that hydrolyze, and it gives corresponding boric acid and corresponding alcohol. R might be the primary, secondary or tertiary alcohol. So if we can synthesize the alcohol, then not only that, actually that can be oxidized to aldehyde, to ketone, as well as acid, ester, and so many compounds. And so from this compound, if we can synthesize, then different compounds we can actually synthesize from the this alcohol. So it has a versatile uses in the organic chemistry, and throughout the world, actually more than 100 research group in the world, they are working in the hydroboration reaction for development, as well as their advanced they are doing advanced research for their different applications. Now the reaction actually reaction mechanism actually that is shown, or already I told you, that is the addition of the hydride as well as BH2, that is the syn fashion. Actually syn means from the same phase of the double bond, and this is the transition state. This is the transition state, and when it is actually bond breaking and bond making is occur, then one hydride is attached to this carbon, which contains the more at least hydrogen, or here it is the more hydrogen, so that attached to BH2. So this is it follow the anti-Markovnikov rule. So concerted transition state, that is known as concerted transition state. This one is the concerted transition state. And in this state, CH and CB bonds are formed at approximately same time, means the simultaneously. And it follow the sine anti-Markovnikov addition and regioselectivity. It follow the regioselectivity as a anti-Markovnikov rule, And what I told you, that is again shown here. Actually, how it is the hydrolyzed in presence of peroxide. Actually, hydrogen peroxide in presence of base that forms the peroxide anion, and peroxide anion that attach to the boron. And this total alkyl group, if we consider this one is the R, then that will be transferred to this corresponding alkoxy group, peroxide oxygen, and at the same time expulsion of the OH. So you will get their corresponding alcohol. Now the steps separately here is represented here. You see this is the peroxide that abstract the base proton, and it forms the sodium salt of hydrogen peroxide, and this sodium hydroxide, sodium salt of peroxide that attacked the boron, and this is the peroxy adduct with alkyl group, and this alkyl group means this boron carbon bond.
Can you show one more time?
Yes, why not? Follow this one.
Yes.
Yes.
Okay.
Then any question? Okay. So next, this is the steps. Actually, the hydrogen peroxide attached to the BH2. Now this total alkyl group, that is the attached boron carbon bond, that will shifted to this oxygen. At the same time, OH will be actually cleaved. Means it will be clipped, means actually OH will be released, and again it will act as a base, means as a catalyst. So this is the total bond making and bond making which is involved in the reaction. So all these steps in of hydroboration reaction are discovered as well as actually published, and this reaction get their recognition. So in the total reaction, this is very important. That is which bonds are formed in these steps. Actually, when alkyl group is shifted to this oxygen, you see here new carbon oxygen bond, that is actually carbon oxygen new bond is formed, and oxygen bond is breaking, as well as boron carbon bond is breaking. So two bonds are breaking and one bond, new bond is making. Okay, so this is the formation of carbon oxygen bond, and followed by hydrolysis, just it gives corresponding boric acid as well as their corresponding alcohol. So all these actually Bolo? Yes.
Can you please repeat the rearrangement? I cannot understand how it occurred.
Yes. You see here the hydrogen peroxide, that is the peroxy anion, that actually donates its electron pair to the vacant p orbital of boron. Okay. Now it becomes negative. So when it is negative, so always it try to release its negative charge. So how it is possible? If it is release the carbon ion, actually as a carbon ion that actually shifted to this oxygen. So as it shifted, automatically oxygen bond with the heterocyclic cleaving, the OH that become expelled, actually released, as well as the new carbon ion and oxygen bond actually that formed. So this is the oxygen carbon bond, new carbon bond formed, but BH2 that remain unaltered. At the same time, OH minus means the sodium hydroxide that newly generated. Is it clear?
Yes, it is clear. Thank you, sir.
Okay. Very good. So this is the just I give you the touch about the mechanism of hydroboration reaction, but it's have a versatile uses. At the end of the class, if you like, then I will say you the life history of H.C. Brown and why it is not become a Brown reaction, but it is known to us as a hydroboration reaction, that I will explain, and I think you will enjoy the story. Now I will say you about the next important reaction in the organic chemistry, and this is a recent, almost we can say this is the recent reaction, recently discovered, means just a 30 within 30 years before, but hydroboration reaction that discovered in 1940, around 45 44 like this. So in that respect, actually, or olefin metathesis reaction, is quite a new reaction. New reaction means within the 25 or 20 years before. And first of all, I will say you the importance about the metathesis reaction. Actually, metathesis reaction, actually chemist, those who are not able to understand, cannot expect is it possible or not, but that have been done by actually by Professor Grabs. Actually, what he did the reaction in his reaction, you see here two alkene. This is one alkene that is with substituent R dash and R dash, and this is another alkene R double dash R double dash. R dash means might be the methyl, might be ethyl, might be phenyl, might be the benzyl, or R2, that also the same. If it is the methyl, then it will be ethyl. It will be the ethyl, it might be the isopropyl. So these are the simple alkyl substituent. In presence of catalyst, actually Professor Grabs got new alkene, but with a different substituent. Means you see here the first product. This is the product. Actually, these are the reagents. These are the actually substrate, and these are the products. So in a new products, actually what has happened? You see here carefully that actually substituent have been actually exchanged. Substituent have been exchanged in both the products. In presence of catalyst. So in a simple simple way, what is more about this? What is the importance? Is there any advantage? Apparently you think no, sir. What is this? Just only the methyl become ethyl become isopropyl. But it is very important and is a milestone in the development of chemistry. Actually, chemists were expecting to design different compounds, particularly in the actually oil industry, particularly the diesel and petrol. They are actually composition in different polymers, in drug, in different insecticides, pesticides, as well as some perfumes, and nowadays which is commonly known to us, that is the smart materials. So to develop new materials, that is known as smart materials, that is very important to exchange the alkyl group with the carbon-carbon double bond, because this carbon-carbon double bond that polymerized, and this polymer are can be utilized. I think all you know, it is known as the age of polymer. Actually, from the morning to night when you are going to the bed, each and every moment we use polymer. Except polymer, we cannot survive. Okay, our actually pen, paper, clothes, everything, our furnitures, each and everything are polymer. So to develop the polymers for their different longevity, their material strength, so many parameters that can be changed if you can change the alkyl group. See, this alkyl group in the polymer that play the important role. So Professor Grabs make a catalyst, and that catalyst have a capability to exchange this alkyl group. So it is those who are just the beginner of organic chemist, they think it is not so. It is why it is so important. But yes, it is important. Just I will say you one fact. Uh, don't take it as a serious. Just it is take as a joke. Jokes have you seen? Yes, actually we see, or generally we observe in our society, for any problem, actually the people is going to the doctors for actually transplantation of kidney, liver, even heart, lungs. Okay, nowadays lungs and heart also can be transplanted. Okay, I think it is not so new, not so new, but even the people are going to doctors actually to change their actually gender, to change their gender. Particularly Michael Jackson, I think all you know, he changed his gender, though he is not as actually now in our he just not surviving is actually not that was a different issue for his death, but I nothing to say about that. So actually this can be common, this can be common nowadays. But have you heard the people are going to the surgeon and ask to doctor, sir, I will change my right hand to right hand, I will replace the right hand to the left hand and left hand to right hand? Have you heard? Hello?
No, sir.
No,
No.
sir.
Why?
Sir.
Why? Actually, this is people
So,
should some facility actually fascination that for a few days I will change use my left hand as a right hand, right hand for left hand. Okay, but people are not going there because it is not have so not have any utility as well as any advantage. But it is actually rare. It is not seen. But exchange of alkyl group, chemists thought it is impossible. But in presence of catalyst, particularly Grab's catalyst, this can be changed as well as their application is enormous. You cannot imagine. In the total smart materials that have been changed, only the uses of the Grab's catalyst, and they make the different alkenes which can be utilized for their future development of smart materials. And parallelly, actually another professor Richard Socks, he also developed another catalyst, though they are actually the aim was almost same, but purpose quite different. Purpose quite different. So you see here what they have synthesized. Actually, this is the SOX catalyst. SOX catalyst, this is the Grab's catalyst. This is the Grab's is the pioneer. He started the first this work, and parallelly SOX also did the same work. But I will say you the few words about the Grab's catalyst first. Actually, Grab's catalyst, what is this? This is the ruthenium based complexes. Actually, I think all you know ruthenium is octahedral, forms octahedral complex. And this one actually you see here tricyclopentyl phosphine, two groups attached to the ruthenium and two chloro ligand. At the same time, ruthenium is attached to carbene. Actually, carbon metal double bond. Carbon metal double bond, that is very very important because it is the I will not say the new area, but it is so developing, and that actually help us to grow the different to synthesize different compounds. So organometallic compound chemistry, organometallic chemistry that deals with the subject with the carbon metal bond that is covalent but ionic in nature. So he Professor Grabs first synthesized the benzyl radical, that is the carbene, sorry, not carbene. Carbene is a one intermediate that actually forms ruthenium benzyl double bond, double bond. And this catalyst that can be act as a actually exchange of the alkyl group of the alkene. But only one catalyst that is not 100% used for a particular purpose as well as their efficiency. So research going on, and different catalysts were developed by the same group, Professor Grabs. And you see here also the almost the backbone is same, but here it is the carbene that attached to the ruthenium with the substituent. This is the phenyl substituent, that is the phenyl amine, actually heterocyclic compound with two phenyl group, and their orientation in space that a definite, and two chlorine group as well as one tricyclo phosphine, cyclopentyl phosphine with the benzyl group. And again, this is the third generation Grabs catalyst, actually third generation development, that is the ruthenium with two chlorine, one carbene, and this is the actually alkoxy, and that is the phenoxy attached to the ruthenium. So these are the three catalysts just I am presenting here, that developed by the Professor Grabs, and he was able to synthesize several kinds of compound where it was demanded by the researchers for exchange their alkyl group in the alkene. But he successfully did these things. What I told you, that is written in this paragraph. I will not read you. I will give you the PowerPoint next after next class. So what I told you, that is written in this paragraph. At the parallelly, Professor Sachs also developed the same almost similar type of compound, but the metal is different. Here is the molybdenum. Here you see here the molybdenum, and molybdenum also the hexacoordinated, and here that attached with the nitrine as well as the carbene. So 2 to 4 side of the octahedrals that actually occupied by nitrine and carbene, and two sides are occupied by the phenoxy anion, and this is the biphenyls. Actually phenyl group means the benzene and benzene attached directly, that is the biphenyl, and this is the substituted biphenyls. Actually these substituted actually 2,3 dimethyl 4 tertiary butyl 1 phenoxy anion that actually attached to the molybdenum. And here is the next actually catalyst that also developed by the same research group of Professor Sachs, and this is also the carbene as well as the carbene as well as the nitrine and phenoxy. It is not a phenoxy, this is the alkoxy, but attached with the trifluoromethane. So these substituent in space that have a particular role for their actually transfer of alkyl group, and he also developed the three compounds. But nowadays, if you have more interest about these reactions, then so many compounds, catalysts that have developed based on molybdenum actually as a advanced catalyst for the same purpose. Here this is the tertiary butoxide instead of actually the same substituent that actually taken, and these three catalysts also used, but their aim almost same, but purpose is different. Actually in some cases it is used for the petroleum industry, but in some cases it is used for polymer industry, or in some cases it is used for drug chemistry and steroid, as well as different other smart materials what we demanded. So these catalysts that play the important role for their synthesis, and after completing the reaction that remain unaltered, that can be actually reused. So Professor Sachs and Professor Grabs developed the reaction, and throughout the globe, actually chemists were so pleased on their discovery. But yes, these reactions was at the time of 1985-90, when we were master students. My teacher told us actually such type of reaction is published in journal, that is a milestone in the development of chemistry. But these Professor Stocks and Grabs were not actually nominated for Nobel Prize. Actually, a Nobel Committee not recommended because the mechanism of the reaction is not explained by Stocks and Grabs. So you imagine what I told you, the importance of the mechanism. If it is not proposed, but your application of your reaction is enormous, that can change the dimension of our daily life, but they were not awarded Nobel at that time because they were not able to propose the mechanism. So it take time to propose the mechanism. After 10 years, Professor Professor Vyas actually able to propose the mechanism, and this is the mechanism how the reaction actually conducted, and this is the photograph of Vyas Chauvin, and he proposed the mechanism, and these three triads they were awarded Nobel in 2005. In 2005. So you imagine what is the importance of the compound, importance of the mechanism. Until or unless you cannot propose the mechanism, then it will be not 100% satisfied by the research community, means the scientist community. So when it was discovered, when it is accepted throughout the globe, then they were awarded Nobel in 2005. So this reaction is also a milestone, and now I will show you the mechanism of the metathesis reaction. In metathesis reaction, the mechanism you see here, this is the catalyst. M means other other coordinating groups are not shown here because when you are presenting the when you have to present the mechanism, then you have to show the change in the elementary steps, that is the bond making and bond breaking, but which remain unaltered. If you show that one, then it will be the clumsy because it is a three-dimensional, a bulky molecules. If you show this molecule, you see the SOX catalyst. This is the SOX catalyst. If you show here around this metal, means this is the, if it is the SOX, then it is the molybdenum. If it is the Grab's catalyst, then it is the ruthenium. So just for simplicity, it represented as a M. And what is the double bond, carbon carbon double bond? That is the carbene. That is very important. Actually, we are more interested about the carbon metal double bond. That is the organometallic part. And what is why is the total substituent, which one you like to exchange, that you have to make. So y means this is the diphenyl one phenyl benzyl system, benzyl carbene. So M double bond Y means this is the total things. Actually Y means this is that substituent, that is the phenyl carbon carbon double bond. Okay, am I right? Is it clear? Hello.
Yes, sir.
Okay. Now about the alkene. You see here the alkene, it might be the cis or trans. Alkene means the substituent might be the same side, then it is the cis. If it is they are in opposite side, then it is trans. So whether it might be the cis or trans, that is immaterial as per your requirements, as per demand, as per availability. Actually, you have to choose your substrate. So this is the very simple. It is the substrate and carbon carbon double bond is there. So when these two catalysts as well as your substrate are taken in a reaction situ, then what happened? Actually, this carbon-carbon double bond pi electron that actually donated towards the metal vacant orbital, and it forms a metal carbon bond, metal carbon sigma bond, another carbon carbon single bond. You see here, this is the carbon carbon sigma bond, sorry, sigma bond. Single bond means carbon sigma bond. So two new bonds form and two pi bonds that break. So which one the pi bond? Pi bond from the carbene one break, and pi bond from the carbon-carbon double bond. So 2 pi bond breaks and 2 carbon-carbon sigma bond forms. So simultaneous process. So as per our definition of mechanism, the elementary steps means the change of your bonding, that whether it might be the complete exchange of the electron, might be the sharing or something. So here it is the just sharing. So metal carbon new bond is formed and carbon carbon new sigma bonds are formed. Is it clear? Hello?
Yes, sir.
Okay. So next step, this is a transition state. It is very unstable. So naturally it try to rearrange and it come to become a lower potential substrate. So that will rearrange. So this metal carbon bond, this metal and Y attached carbon, that will break. At the same time, this carbon carbon bond that will break, this carbon carbon bond, and new metal carbon double bond will form and carbon carbon double bond will form. So you see here we get from there the metal metal carbon bond, but that take the R minus and your R group is exchanged with the alkene attached to R dash, and that is also alkene, but it is cis, becomes cis. So geometry also changed. So that reaction, actually this is the two-step reaction only just proposed by Chauvin, and you imagine become a Nobel laureate. Do you follow me? Do you
Yes, sir.
follow me?
Yes, sir.
So what is its important of the reaction? So organic reaction mechanism is very important. My research group, they are also working on inorganic reaction mechanism. Okay, and to propose a mechanism, it take near about 2 to 3 years, 4 years. Okay, so mechanism is very very important to propose a mechanism. Okay, so that reaction is shown in the cyclic manner. You see here, this is the substrate, means actually this is the metal catalyst, and this is the alkene. What I told you, that forms the four membered ring. This one the same thing, and this metal carbon as well as carbon carbon, that bond break and new alkene with exchanged alkyl group that form, and catalyst with the metal carbon double bond with R group that regenerate. And again another molecule of alkane that take part in the reaction with the catalyst, and that also form the four membered ring, and this four membered ring again dissociate to give the alkene, and again another new molecules that take part. So in such a way the cycles that complete and catalysts remain unchanged and that reused. Do you follow me? So you imagine what is the importance of the reactions and what is the importance of the mechanism. So until or unless it is proposed, so that is meaningless. That is meaningless. So mechanism is very important. So why we have include this one? That is so. That is also actually highlighted in this chapter. In this chapter. So if you have more interest about the SOX catalyst or Grabs catalyst, so these are the latest advanced at different catalysts that has been synthesized and that can be used for different purpose. And this is the actually what I say, this is the reference that the journal Chem that published in 2002, and they were awarded Nobel. This is Professor Chauvin. Actually, one thing, they were actually good relation between Grabs and Chauvin, but relation with the Vas Chauvin was not so good. Actually, at the time of Nobel lecture, though they have appeared in the same screen, you see, they did not appear in the same screen, but you see here actually Sox and Robert Grabs, they appear in the same screen and gave their photo, but Chauvin not appeared there. Actually, he demanded that he should be only the awarded Nobel for this purpose. But Nobel committee recommend these 3 persons to share his Nobel as 1/3. Okay, so is it interesting what I told you, the story as well as the science? Hello.
Yes, sir. Sir, can
Interesting.
you
বলো। Yes.
Sir, on the initiation step, sir, can you tell that after the reversible step, why is the tendency to move forward?
Yes, that is very important. Always remember that transition state or intermediate, it is very, very unstable. Unstable means your potential energy is high. So each and every object as well as tendency of a human beings or any reactant that comes to the lower potential energy. So it goes to the lower potential energy through rearrangement of bonds, and ultimately that gives the alkene with a new substituent as well as the catalyst that regenerate. Do you follow me?
Yes, sir.
Is it clear or I have to repeat it again? I have to say in different way.
Uh, Sir, but it can go to reverse now.
Yes, actually it is a reversible process, but reversibility you can control by applying temperature, pressure. Actually, always remember this reaction just simple it is presented. It is very difficult to conduct in a laboratory. All these things are patented. Do you follow me? So this reversible reaction, if you have to make it forward, then you have to change the condition which helps them that one. At the same time, as it will decompose, so forward reaction will be favored. Do you follow me? So it is a simultaneous process. Is it clear? Hello.
Yes, sir, it is clear.
Okay, okay.
Yes, sir, it
So
is clear.
okay, so I will say you within the 5 minutes if you have time, enough time. Then within 5 minutes I will say the life history of H.C. Brown. Do you like to heard?
Sir, we have class from.
Okay. So next day I will try to say you. Okay. So leave. Okay. So
Sir,
I'm
can you
leaving.
provide us? Sir, can you provide us the PDF?
Yes, next day when I will complete the total discussion of this chapter week I will complete this one and I will give you in your MS team. Okay.
Okay, sir.
Sir,
Okay.
if you can give before, then we can come prepared.
Yeah. Hello. Hello.
Sir, he says if you can give
Sir,
us right now, we can prepare for it.
Now right now means actually if I provide today, then you will not attend the class or you will not pay your attention in your class. So next day when we will complete at that moment I will just upload this one. Okay. Do you follow me? Now you try to find out from internet, Google, as well as if you have any book and you try to read or try to gather knowledge as well as your notes if you like, and finally I will give you no doubt. Okay. Hello.
Okay. Okay,
Okay,
sir.
sir.
Okay. Okay. So do you have any question what I have discussed today? Hello. Hello.
No,
Hello.
sir.
Or don't have any question? Okay, very good, very good. Chalo.
Sir, please stop the recording.
Are you hear me? Do you have any question? Are you asking any?
Sir,
Hello.
please stop the recording.
Repeat it again. Hello.
Sir,
Hello.
please stop recording. Hello, sir.
Oh, stop recording. Yeah, আচ্ছা 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 রেকর্ডিং স্টপ করব কোথা থেকে রে ও আচ্ছা এখান থেকে করতে হবে না হ্যাঁ স্টপ রেকর্ডিং ওকে আই ডিড ইট